Let's take a look at the horizontal drilling and stimulation processes that have made shale exploration so successful. A drill bit is mounted on the end of the drill pipe. As the bit grinds away, a mixture of water and additives called mud is pumped into the hole to cool the bit and flush the cuttings to the surface. The mud also cakes on the walls of the wellbore, keeping it intact. Similar to a vertical well, the hole is drilled to just under the deepest fresh water near the surface. The drill pipe and bit are then removed. Surface casing is inserted into the drilled hole to isolate the fresh water zone and also serves as a foundation for the blowout preventer, a safety device that connects the rig to the wellbore. Then, cement is pumped down the casing and out through the opening of the shoe at the bottom of the casing. It is then forced up between the casing and the hole, sealing off the wellbore from the fresh water. The cementing process prevents contamination of the freshwater aquifers. The pipe and bit are lowered back down the hole to drill through the plug and cement, and continue the vertical section of the well to approximately 500 feet above the planned horizontal leg. This depth is called the kickoff point, where the curve will begin so the horizontal section can be drilled. Up to this point, the process is the same as drilling a vertical well. Again, the pipe and bit are pulled out of the hole, and a downhole drilling motor with measurement while drilling instruments is lowered back into the hole to begin the angle building process. The distance to make the curve from the kickoff point to where the wellbore becomes horizontal is just under 1/4 mile. Once the curve is completed, drilling begins on the well's horizontal section, called the lateral. The pipe used to drill the well measures 30 feet in length and weighs approximately 495 pounds each. It takes over 350 pieces of pipe weighing nearly 87 tons to drill a 10,500-foot well. At various stages of drilling, the pipe is taken out of the hole for tool and bit changes and put back in. This process is called tripping pipe. When the targeted distance is reached, the drill pipe and bit are removed from the wellbore one last time. Production casing is now inserted into the full length of the wellbore. Cement is again pumped down the casing and out through the hole in the casing shoe, forcing the cement up between the casing and the wall of the hole, filling the open space known as the annulus. Casing the well is a very important process because it permanently secures the wellbore and it prevents hydrocarbons and other fluids from seeping out into the formation as they are brought to the surface. At this point, the drilling rig is no longer needed. A temporary wellhead is installed and the location is prepared for the service crew who will perf, frack, and prepare the well for production. The first of these steps is to perf, or perforate the casing. A perforating gun is lowered by wire line into the casing to the targeted section of the horizontal leg. An electrical current is sent down the wire line to the perf gun and sets off a charge that shoots small holes through the casing and cement, and out a short distance into the shale formation. The perf gun is then pulled out of the hole. Next, because the shale is tight or compressed, the well will have to be fracked. Known as hydraulic fracturing, this is a process where water, sand, and additives are pumped into the wellbore and down the casing under extremely high pressure. As the mixture is forced out through the perforations and into the surrounding rock, the pressure causes the shale to fracture. This creates a fairway connecting the reservoir to the well and allows the released gas to flow to the wellbore. Next, a temporary plug is placed at the heel or left side of the first stage frac. The plug closes off or isolates the perforated and fracked section of the wellbore so that the second stage section of the horizontal leg can be perforated and fracked. Tight reservoirs do not contain natural fractures and therefore cannot be produced economically without hydraulic fracturing. The permeability is increased by providing pathways through which gas can flow more easily. With advancements in technology, multi-stage fracking has become the standard for tight gas reservoirs. This process of perfing and fracking can be repeated several times to cover the entire horizontal distance of the wellbore. Once fracking is completed, the plugs are drilled out, allowing the gas to flow up the wellbore. The next step is to install a permanent wellhead, also known as a Christmas tree, and other necessary surface equipment. A pipeline is then built to transport the gas to the pipeline network. As field development expands, additional pipeline infrastructure is built. Thanks to the vision and persistence of those who have perfected these new technologies, shale plays have become an innovative and highly productive source of new energy for our country.